Hi everyone, welcome back to the channel. In this series, we are going over Leetcode problems, and today we're looking at Leetcode 155 Min Stack. Now, I'm not sure if you'll ever see this in an interview or how much, interviewers are going to want you to implement a data structure like this. But it is in our problem list, so we're going to go over it, and I think it's a really interesting problem to look at. So the problem says, design a stack that supports push, pop, pop, and retrieving the minimum element in constant time. So they want us to implement a data structure that is basically a stack, but in addition to that, they want a function that can or method that can return the minimum element in the stack. Okay. So in the editorial for Leetcode, they do mention using a stack to implement this, to solve this, but today we're not going to use that for two reasons. And number one is if you're using Java, we don't really use stacks anymore. It's usually a deck that's preferred or a different data structure than stack. It's a legacy data structure. But if you think about this is Leetcode 155. I'm not sure when this problem came out, but Leetcode came out in 2015. So it is about 10 years old. And I'm not sure if that got updated since, but we're going to go ahead and use a linked list today. Now, the second reason is that I don't want to use a stack to implement another stack. I would rather build this on my own under the hood because it gives us more clarity of what's going on, and I just want to show off some Java skills. Okay, so let's go ahead and get that started. Now, like I said, we're going to use a linked list, so I do need to make my nodes. And I'm going to make this node class have an additional value in there. And so we're going to keep track of the current value, the minimum value at the time that that node is getting pushed onto our stack. So that's what this min value is going to be. And then the next is going to be, our node's next, the next node that are in our linked list that it's pointing to. Go ahead and make the constructor. Okay. So in our min stack, we're going to immediately initialize our head to be null, especially if it's empty. And now we have our next method that we need to create, and that's the push. So what we're going to want to do is we're going to want to create our first node, or if it's already created, then we'll want to create the next node. Okay, but here we want to check for that because we do need to use that minimum value when we are pushing on to the stack. So first I'm going to check if our head is currently null. And if it is null, we can just go ahead and create a new node with its current value. The current value, since it's the only node in our linked list, it's just going to be that itself. The value will be our minimum value. Otherwise, if the head already exists, then our head is going to be equal to a new node. But in this instance, we want to take the value. And then for Java, I'm going to use the math library for this, and we'll pull its minimum, and we'll pass in the current value versus our current head's minimum. And whatever is the lower value for each of those, it will be set to our minimum. And then after that, I'm going to set our next node to be the head. Okay, so that's what that's pushing is going to do. It's just going to add a node. Now we have our next method, and that's going to be pop. So a pop is when we remove the item. And if it's the head, then all we have to do for linked list is we're going to update our current head to be the head dot next. And that's going to remove our current head. And for top, the top is going to return the top value. So we're just going to return our current head, the value of our current head. Now, for this method, when we were pushing on to our linked lists or our stack, we have been keeping track of the current minimum for each of those. As soon as a new node, a new head gets put on, we know that we have the current minimum already set on that node. And if you keep popping that off and then you call get minimum, you might have a new number, but because it's a stack and whatever, like the last in, first out method, what's happening is you're always going to have the nodes minimum at that time that it was pushed on, so it would be equal to when it's getting pushed off. So simply, because we've been keeping track of that, we can return our minimum value that's on our head. I'm going to go ahead and run that. Bring that up, and our test cases have passed, and I'll submit it just to make sure. And as you can see, this beats 99.37%. That is it for minimum stack. If you solved it in a different way, I'm not sure which way that would be, but if you solved it in a different way, or you do want to see how you would implement it with the stack, comment below. I would love to hear from you. Thank you. See you in the next video.